Probably should have started the video after I did this, but oh well. It's Wednesdays we have. Any questions? The last thing we did, we started in the rotational stuff, didn't we?
Or
You wrote a bunch of.
we wrote
Oh,
the
we just,
formulas.
momentum. We ended on momentum stuff.
Right. We wrote the
We did
form.
momentum,
We
and
wrote
then
the
we did-
formulas of the linear versus angular.
Okay, we did get that far. All right. Let's justify it. Live.
Yeah.
Next semester is 152 or 252.
Oh, you know. Actually, this can be safe.
That beeping is going to get annoying. All right, Stan, you were about to say something?
No, it can be saved for later.
Okay.
Yeah, the class.
Let's just start out with, I have a door. And I'm going to simplify the door and just incredibly skinny, and I have a hinge at the very end. Not exactly what we have here, but close enough. So it's rotating about that center point. And I want to figure out the kinetic energy of the door. Well, you all know the formula. And what is the formula for kinetic energy?
1/2 mv squared.
Thank you. What do we use for speed?
V.
Pardon?
V. The V.
Well, okay, yeah, the symbol, but if I have a door that's spinning around, let's say that it takes 3 seconds to go all the way around. And let's make this 5 meters. It is a huge door. What would you choose for the speed of the door?
Cake formula?
Which one?
Delta X equals VIT plus 1/2 AT
Squared.
squared.
That would tell us displacement. Doesn't tell us speed. And that assumes constant acceleration, which we do not have here. All right, suppose we wanted to approximate, what would be just a quick and dirty crude estimate, approximation for the speed of the door?
Was it doing a full?
5/3.
Yeah, doing a full 360. Dave, what'd you say?
That was stuff.
Stone, what'd you say?
5/3 meters per second.
And you got 5/3 just by that distance over that
I
time?
think, yeah.
Except the door's not traveling that distance, the door's traveling that
Oh, yeah.
distance.
Oh, it'd be so that it'd be 2 pi. 10 pi over 3.
So you're taking the speed of this part of the door right here.
Okay.
That, it sounded like that's, when you said 10 pi.
I guess.
Okay. Logan, you were saying something before.
Yeah, I was gonna throw some radians in there, so,
Yeah,
but, are we measuring the outer edge or
The whole door. I
somewhere
think.
else?
that's the question.
Is it a cake formula?
Pardon?
Is it a cake formula?
It is not.
Okay.
A cake formula assumes constant acceleration, but at any point on that door, the direction is constantly changing, so acceleration is not constant. All right, so if we pick the outer part of the door here, then the speed of that outer part, I'll just label this as point A. The speed of A is going to be, well, distance over time,
Right, that
which
was-
would be 2 pi r over the period. So capital T for period, I feel like, yeah, we've done that before.
Yeah.
And so in this particular case at point A, this would be 10 pi over 3, which is roughly 11 meters per second. What's wrong with, so it's, as a quick and dirty approximation, sure. Well, what's wrong with using that as the actual value, not quick and dirty?
What's the question?
We are already assuming it makes a full rotation, right?
Yes.
Okay.
What did you ask?
The first question was, as a quick and dirty approximation, what would you use for the speed? We have roughly 11 meters per second.
Does that also assume that it's going the same speed the whole time?
That assumes that the angular speed is constant,
Okay.
and that, well, that it would be the average speed if it weren't constant, as long as that's still 3 seconds. But that's the speed at this point on the end.
Okay.
Why can we not use that as, why can't we just plug that into there and go, we're done?
Were we not trying to find the speed of the whole door, or were we trying to find that point?
Well, this is the formula for kinetic energy.
Yes.
So the question I asked first was, what speed should we use for the door?
Oh, okay.
So first off, is the speed of the door, is every part of the door traveling the same speed?
No,
No.
no,
Why not?
because the end point will be moving more than the point at the, like, start of the door, the end of, towards the center of it.
All right, so the farther you are from the door, the faster it's traveling, the farther it travels.
Yes.
Yeah.
Okay, and that's true, because this point in the middle of the door is traveling that far, that's a smaller circle than that. So the farther out you go, the faster you're traveling, so not everything is traveling the same speed. So we could choose the endpoint, that would give us an upper bound. We could choose this point down here, that would give us a lower bound, that would be 0.
What if we used like radians per second?
But we'd have to somehow translate into speed. V is in the equation there, not omega, yet.
Take the middle. Use the middle.
Okay, we could use the middle. So it'd be pi times, I guess that's 2.5 times 2, so that'd be 5 pi over 3, which is roughly 5 point something. These numbers obviously made up on the spot. Now, we could do it with either the smallest, the largest, or somewhere in the middle. I'm gonna take the one in the middle just for the sake of what we continue doing, although in another class, they set their minds on that one, so we stuck with that. What I'm getting towards is that we can come up with a better approximation if we consider it in 2 pieces.
So, again, the first crude way of doing it only accounts for the average speed of that point of the door.
Yes.
Because, and I can't use it because different parts of the door are going at different speeds.
Correct.
Okay.
Yep. So if instead I treated it as 2 things, got my door right there, still traveling around, doing 2 pi radians in 3 seconds. I'm gonna treat it like 2 different pieces here. So then my kinetic energy I'll call this 1 and 2. My total kinetic energy be 1/2 times mass of part 1 times the speed of 1 squared plus 1/2 mass 2 times speed of 2 squared. I should get a better approximation at least. Mass 1, mass 2, if I cut it perfectly in half, then this would be half of the original mass. So this would be 1/4 times the total mass times speed of 1 squared plus 1/4 total mass speed of 2 squared. Let's actually stick some numbers in this. So let's say the mass of the door is 10 kilograms, just to make the math easier. And so if we went for just the middle, we'd have 1/2 times 10 times, if someone could actually find the value of that, please.
5.24.
5.24 squared. And what is the kinetic energy if using the middle as our approximate? One
137.3.
unit?
Joules.
Yes, like a unit.
Joules.
If we broke it in half, I have 1/4 times 10 times,
Why is it 1/4?
I broke the mass up into 2 pieces, so technically that's 5 and 5. So this is half of the total mass,
Oh, okay.
so that's where that came from. Or we could just do it 1/2 times 5 times the speed of this one, so if it's in 2 pieces, that's 2.5, so this becomes, oh wait, no, that's 5. That's 2.5. So that right there would be 1.25. So it becomes 2.5 pi over 3 squared. So that's 1/2 times 5 times, that's at, should make that 10. Let's do 3.75. 3.75 times 2. What do we get?
$2.5 pi over 3?
2.5 pi over 3. Yes, yes.
Wait, why is it 7.5?
Yeah,
the
because the
middle.
distance from here to the middle of that second segment is 3.75 meters.
Yeah.
And then 2 pi r, you got 2 times r. That's where the 7.5 comes from. Tell you on the calculator, did you get an answer?
I did not put 7.5, so my answer's wrong.
Okay.
160.7576.
Units?
Is this in joules?
It is also in joules. All right, and are we trusting Logan or are we? Looks like you believe in it.
And why is it 7.5? Sorry?
This is the speed, so it's distance divided by time.
Right.
The distance is 2 pi r. The first part right here, well, the whole thing is 5 meters long. So half the door is 2.5 meters long. and then half of that is 1.25, so that's where, so 2 times 1.25 is 2.5. This spot right here is halfway between 2.5 and 5, so that's 3.75. 2 times that is 7.5.
Okay.
So we get a different answer doing this. We're gonna do one more and then we'll generalize it. So if I broke it into 3 pieces, the whole thing is 5, so this would be 5/3, 10/3, 15/3. So the halfway point would be 5/6. This would be 5/3 plus 5/6, so 15/6. And this would be 10/3 plus 5/6, so 25/6. And so it would be 1/2 times the mass, 10/3, times 5/6, so 5/3 pi over 3 squared, plus 1/2 times 10/3 times 15/3 pi over 3 squared, plus 1/2 times 10/3 times 25/3 pi over 3 squared. And if we can get that, then we will acknowledge that this is a very long way of doing it. And if someone would be kind enough. Or resort to my making up numbers.
So why did we split the door not like directly in half? There's like 1/2 is 1.25 meters and the other one is 3.75.
So if I've got a system of objects, so I've got multiple particles and I want to find the total kinetic energy. I find the kinetic energy of each part and add them together.
Okay.
So what I'm doing here is suggesting that we can get a better value for the kinetic energy by breaking it up into multiple parts.
Yeah.
So, okay.
Yeah,
So,
I was just why
I missed the question then.
why isn't it directly in half?
Why? So that the mass was easier.
Okay.
Ultimately, it doesn't have to be,
Alright.
but
I
we're
was
going.
thinking that. Second question.
Yep.
Those 1/4 mv squared and then the rest, what is that for?
I was taking this, since I broke it directly in half, mass 1 would be half of the total mass. Mass 2 would be half of the total mass. So I did 1/2 of times 1/2 times the total mass, so that's 1/4 of the total mass.
Yeah.
Or you could just do 1/2 of half the mass. And I started out doing this and then switched to just that.
Okay, because it did look kind of not connected, so is that like?
Yeah,
Snap.
it's, that's the total mass. Okay. Now, Giovanni does not know the question, but he's gonna give us the answer. Go.
10/3.
All right, let's see how close he is.
I was gonna ask, has it ever worked for you, but of course.
It has
hasn't.
never.
Yeah, of course it hasn't.
Most students will just look at me blankly. And in some classes, I keep getting the response of, what's the question? Which sort of spoils it. Thank you, Giovanni. All right, we have an answer?
I think this is right. I don't know.
What do you got?
177.69. That's right.
What was it gonna say, do 7 minutes of type this in, so maybe it's.
All right, eventually we might get confirmation. It makes sense that we started at 137.3, then we went up, and then we went up again, but not as much as we went up last time, and presumably we will eventually narrow in on the actual answer. All right, so we'll assume this is correct, unless somebody corrects it. All right, so obviously, this is a very tedious way of doing it, so let's crank it up, and there it is. So what I'm gonna do is, in essence, if I've got 1/2 times mass 1 V1 squared plus 1/2 times mass 2 V2 squared plus 1/2 M3 V3 squared plus however many parts we break it up into, recognize there's a repetitive piece to every single one of those, every one of these. So I can, if I got a repetitive nature like that, I can write it in shorthand notation. Let I equal 1 to however many parts we break it up into, of 1/2 mass of I V sub I squared. So this is just shorthand notation for that. So I'm figuring at this point, most of you have at least seen this notation before. All right, got a couple nods there, a couple of stares. All right, so I have all these terms, repetitive. Each term has 1/2, I can factor 1/2 out. So any constants in here, I can just bring out front. So that's the same as 1/2 times M sub I, V sub I squared. Now notice I did not write I equals